Hello everyone. In today's session, we'll see about what a rectifier is, a basic introduction to half-wave rectifier, which we have discussed in the previous session, and about full-wave rectifiers. So, what a rectifier is? A rectifier is an electrical device that converts or alternating current into direct current by the usage of PN junction diode. So to convert this AC to DC, we can use more than one PN junction diode in our circuit. So how does this rectifier convert AC to DC by using diode? In the sense, my diode will work only when it is connected in forward bias, and my diode does not conduct in reverse bias. So when it is a forward bias, it means the diode is conducting. Generally we call that term to be on. The circuit is on. So when it goes to the reverse bias, the circuit becomes open. So which means it is an off circuit. But what do we generally mean when it is a DC? We just call it as a normal line voltage, which is a value, which is a constant value that is represented using a straight line. But what do you have when this PN junction diode, when it is connected in our circuit in this conversion? Does it give a straight line or not? No, actually this diode does not give a straight line. Instead, we get a signal which is pulsating in nature, which means I have a signal that is present only in the positive portion of my the given input signal. So I can say my given input signal, which is AC, is converted into its DC form. So the circuit that is being used to convert this AC to DC is a half wave rectifier, full wave rectifier, and the bridge rectifier. So coming to this half wave rectifier, we have seen that the half wave rectifier has a transformer setup, a diode, and a load resistor. For the positive half cycle of the given input signal, the diode is in forward bias. So the diode conducts, and the positive cycle is completely reaches the load resistor, and I will be getting the output. But when for this negative cycle of my input signal, I do not get any output because the diode becomes reverse bias, so it does not conduct. So what happens in this positive and reverse bias is that I will have movement of charge carriers into the positive and the negative part of my diode, due to which the circuit turns on and off alternatively for the in correspondence with the positive and the negative half cycle that I am giving. Next, coming to this half wave rectifier, what this half wave rectifier does, as I have already told you, this is a closed switch. When I am giving my input signal, which is positive, which is there in the positive cycle, the diode is closed, which means the diode is conducting and the circuit is closed. So I will be getting my output. When I'm giving my output, when I'm giving my input signal in the negative part, my circuit becomes open, so the diode does not conduct and I will not be getting the output. Oh, so having a comparison with the input signal and the output signal that I have received, you can see that the output is present wherever I have my input signal, which is there in the positive cycle. So one main disadvantage of this half wave rectifier is the signal whatever is there in the positive cycle alone will be used, and the signal that is there in the negative portion is completely eliminated. So a part of my input signal is being wasted and it is not at all coming into account for this output waveform. So in order to overcome this disadvantage, we are moving to this full wave rectifier. So this full wave rectifier is a device which is similar to my half wave rectifier with few differences. So there I will be using a transformer and one diode, but here in this full wave rectifier I will be using a center taped transformer along with two diodes D1 and D2. So by the usage of this D1 and D2, what happens? My diode D1 will conduct for one portion of the time, which is T1, and my diode D2 will conduct for some amount of time, which is say T2. So this on and off of my diodes will happen alternatively based on the input signal that I am giving. So here, as I already told you, we are using a center taped transformer where the center taped is considered to be the reference voltage. So based on this circuit, based on this connection, my diode will conduct for every half cycle. Only for a positive half cycle, one diode will be conducting, and for the negative half cycle, the other diode will be conducting. So by combining the outputs of the diode D1 and D2, I will be getting an output where I get this alternating, where this AC signal is converted into DC signal. So now we will see about how this full wave rectifier is working. So this is the working of full wave rectifier. Coming on to this full wave rectifier, I have this input signal which is working in the positive half cycle. So whenever I am giving my signal which is there in the positive half cycle, that signal moves towards my diode D1. So initially the polarity of my diode D1 will be plus, and for diode D2 it will be minus. So I am giving the positive half cycle to diode D1, which means the input is plus and the polarity of the diode is also plus. But when it comes to this diode D2, the input signal is plus and the polarity is minus. So plus and minus makes my diode D2 to move to reverse bias, which means the diode D2 is not conducting when I give my positive half cycle as input. So the positive half cycle as input makes my diode D1 to conduct, and D2 moves to reverse bias, so it does not conduct. So the flow will be from the winding to diode D1 and the resistor RL. And coming on to this negative half cycle, when I go to this negative half cycle, what happens? The polarity is actually getting changed. So when I have an input signal which is alternating in nature, the polarity across the terminal where we are giving my input signal will alternatively keep on changing. So initially for the positive half cycle, my diode D1 was with positive polarity and diode D2 was with negative polarity. And now I am moving from positive half cycle to the negative half cycle. When I am moving from positive to negative, the polarity for my diode D1 and D2 will also change. So from diode D1, from the positive polarity it will change to negative polarity, and diode D2 from negative polarity it will change to positive polarity. Okay. So now I am giving my negative signal as input, so which makes my diode D1 to be in reverse bias and diode D2 will be in forward bias. So the flow of signal will be from the windings to the diode D2 and the load resistor. So now I will be getting my output signal across the output part. So now checking on with this output waveform of my input signal and the output signal, if you see, my input waveform is completely alternating in nature, where positive and negative cycles are there. When coming to the output of D1, I have one set of output, and output of D2, I am getting one set of output. So at the final output, I will be combining the outputs of my diode D1 and D2. So I am getting this complete signal. So the positive half cycle as well as the negative half cycle is being completely used. So the main thing in this full wave rectifier of how the diode is making use of the positive and the negative half cycle is, the full wave rectifier uses two diodes and I am using a center taped transformer. By using two diodes, my AC signal is under consideration, where the polarity of the diodes keep changing alternatively, and the use of center taped transformer, where the center taped transformer gives a phase shift for every alternate half cycles. So that is the reason why every signal, whether it is positive or negative of my input signal, I am getting every waveform in the positive cycle itself. So the disadvantage in my half wave rectifier, where portion of my signal is being eliminated, is being rectified in this full wave rectifier, where the given input signal is being completely used and my input signal is getting converted into its DC waveform. So we will see another type of full wave rectifier, which is a bridge rectifier, in the upcoming class, due to one disadvantage in this full wave rectifier. Thank you.